Let's explore graphs of basic exponential functions. Now, the generic way to write an exponential function is y equals a b to the x. Notice that x is a variable. A and b are both constants. All right? Now, at first, we're just going to assume that a is 1. And we're going to talk about exponential functions when a is 1. So let's let, for example, besides a be 1, let's let b be 3. So I'm going to look at the graph of y equals 3 to the x. What's that going to look like? All right, this is going to be a parent function for us, a parent curve. So when x is 0, anything to the 0 power is 1. So when x is 0, y is 1. So this graph is going to go through the point 0, 1. Now, when x is 1, y is 3. All right, so when x is 1, y is 3. And then when x is 2, y is 9. Well, that's way up here. All right? So my curve is going to increase sharply at this point. Now, on the other side, when x is negative 1, then 3 to the negative 1 is really 1 over 3. It's really 1/3. So when x is negative 1, we have a point something like this. And then as x is negative 2, this fraction becomes even smaller. So my curve is going to be very close to this x-axis, and then it's going to swing sharply up in this direction. This is the parent graph for our exponential functions. It does not matter whether we use 3 or 2 or 5 or any number greater than 1. The parent graph will look something like this. All right, now let's tweak this curve a little bit, tweak this equation and see what that graph looks like. So let's suppose we graph y equals 3 to the x plus 2. All right, well, just like other parent graphs that we've looked at, whenever you add or subtract a number from the x, or with the x, then you're moving the curve side to side. So x plus 2 moves to the left, moves the curve left 2 points. So instead of going through the point 0, 1, we now go through the point negative 2, 1. So all my graph does here is this parent graph just moves over 2 places. So we go through this point now instead of this point. All right, now you'll notice that the curve never gets negative. It never goes below the x-axis, and that's because there's no way to get a negative number by raising 3 to some power. There's no way to get a negative answer. So the curve stays above the x-axis. Therefore, we say that this line, y equals 0, is a horizontal asymptote. So your exponential functions have horizontal asymptotes. All right? Now, let's tweak this curve a little bit more. Let's say we're graphing y equals 3 to the x minus 1. Well, now we are adding or subtracting to the function. This means we're going to have a vertical shift. We're moving it up or down. In this case, we're moving the function down 1. Well, when you move this graph down 1, then that horizontal asymptote also moves down 1. So instead of being at the line y equals 0, now my horizontal asymptote is at the line y equals negative 1. So we have a new horizontal asymptote. And instead of going through the point 0, 1, we now go through the origin. So my graph doesn't change other than that. It still curves sharply up on the right, hugs the asymptote on the left. All right? Okay, so now let's do one more change. Let's say that we have y equals 4 minus 3 to the x. Okay, so this can be written as y equals negative 3 to the x plus 4. When I write it this way, I can see that I have my vertical shift, but I also am making my function negative. All right, so when you make the function negative, then you actually reflect it vertically. All right? Because the negative y's are down here. They're not up here. They're down here. So you reflect vertically. All right, so everything shifts up, which means my asymptote also shifts up 4 points. So instead of being the line y equals 0, my asymptote is now the line y equals 4. But my curve, instead of being up here, my curve has reflected across this asymptote, And it now does something like this. So now you can see that my curve is upside down, so to speak. Okay, well, let's do one more tweaking of this basic curve, basic graph, and I'm going to redo my parent graph here, but I'm just going to call it y equals b to the x, where b is any number greater than 1. And remember, this parent graph looks like this. All right? Now, let's suppose, though, that we do y equals 3 to the negative x. Let's graph this curve. Well, if you'll remember from other parent graphs, when we make the x negative, then we have a horizontal reflection because the negative x's are over here. So when we reflect this curve horizontally, instead of rising sharply to the right, it rises sharply to the left. And it hugs the y equals 0 line over here. So you see y equals 3 to the negative x is a decreasing function instead of an increasing function. Notice that my asymptote does not move when I reflect horizontally. All right, so let's look at this 3 to the negative x a little more closely. We can rewrite 3 to the negative x as 3 to the negative 1 to the x. Well, what is 3 to the negative 1? Well, 3 to the negative 1, as we said earlier, is really 1 over 3. So you see that when b is a fraction less than 1, then my parent graph is going to look like this. My parent graph is going to be a horizontally flipped version of this graph. This is the parent graph whenever b is a number that's less than 1. So, for example, if I wanted to graph y equals 5/8 to the x, let's say plus 2, then this graph is going to, the parent graph for this one is going to be this curve, not this one. It's going to be this curve, and we're going to shift it up 2. So we go up 2, which means my asymptote goes up 2. And the curve's going to go through this point, but it's going to be a decreasing function rather than an increasing function. All right, so let's briefly talk about what happens when a is not 1. Well, when a is not 1, then it's very easy. Let's suppose that a is 2. So let's say we have y equals 2 times 3 to the x. So we have a as something other than 3. Well, what happens when x is 0? When x is 0, remember, 3 to the 0 is 1. But what is 1 times 2? Well, it's 2. So you see, and nothing else is really going to change. The asymptote is not going to move because the more negative x gets, the smaller this number gets, the closer to 0 it gets. It's never going to be negative, but it's always going to get closer and closer to 0. The curve is still going to go up, but instead of going through the point 0, it now goes through the point 0, So we say that 2 is an initial value. Where does the curve start? What's the initial value? And it's the number in front, because in many applications, there is no negative y or negative x, and curves are simply in the first quadrant, and they will either start at a number and decrease because b is less than 1, or they will start at a number and increase because b is greater than 1. But this number where the curve starts is a. If a is anything other than 1, then this number is going to be a.